In example two, we have this table to fill in. I really enjoy this example because you're going to be given some information and you have to figure out the other ones. And that information is going to be different for each example A through D. Let's work with the first one here. And if we look at the column, the first column, we've got the horizontal piece, and that's 3 units to the east. So in my vector notation over here in this column, I'm going to write a positive 3. Of course, 3 units to the east would be 3 units to the right. 4 units north is the vertical column. And so what we're going to do is we're going to write that as positive 4 in our vector notation, in our vector ordered pair. We're going to assume here that all of these, by the way, are going to be in standard form. So we can actually draw that if we want to. And we've got 3, 4. So 3, 4 might be this vector here, where that's 3, and that should be a little to the left here. So let's make that right there. And then we've got this guy right here. That would be 4 units. Now we want to find the magnitude. So to find the magnitude of this vector, what we're going to do is we're going to take the square root of each component squared. So the x component and the y component. Those are the legs of that right triangle. So we've got 9 plus 16 here. And the square root of 25 then is equal to 5. So that's our magnitude right here. That's 5. For the direction we're going to have to use the inverse tangent here. And if we think about this, I'll draw this here on the little diagram. We've got basically a right triangle there. And the opposite side is 4. So that's this guy right here. And the adjacent side, of course, would be 3. So opposite and adjacent, we're taking a look at the tangent. And we want to know the angle here. So we're going to use the inverse tangent of 4/3. So if you type that in your calculator, you're going to get approximately 53 degrees. So I'm going to write 53 degrees here. Take the time to pause the video if you need to. If you're getting a decimal that's not 53 degrees, it's possible that you're in the wrong mode. So for these vectors, usually we're going to do these with degrees, not radians. So make sure that you're in degree mode on your calculator, and you can hopefully type that in and get 53 degrees. With the next part, we're given some pieces of information. We have the magnitude now and the direction. So let's just draw this. I like to actually draw these, so that helps me visually see what's going on. So here's 113 degrees, and that could be 13 units. Well, that looks more like 100 and probably 35, but we'll erase that. Try to draw a little bit better one here for you. So there you go. That angle right here that's formed between the positive x-axis and that vector is 113 degrees. And then 13 units would be the length or the size of that vector. Okay, so let's see here. Draw a different one. We'll do this, try to make it a little bit more exact for you. There we go. And there's your direction of rotation right there. Okay, so we got to figure out a few things here. We have to figure out, let's see if we scroll up, we got to do the vector notation, and that's going to come from the horizontal and the vertical pieces. So let's work with the horizontal piece. And for the horizontal piece, this is really the same thing as polar coordinates. So if you know anything about polar coordinates, if you change between the polar coordinate, which basically that's what this is, you've got your r right here, that's the distance. And then you've got your theta right here, which is 113 degrees. You might remember that the x, or the horizontal piece, is just going to be r cosine theta. Now in vectors, we would think about the r as being a magnitude, or the size of the vector. And then the theta here is that standard position angle. So we got 113 degrees. Make sure your calculator is in degree mode. Type this in. You don't need the inverse here because we have the angle. We're not trying to solve for an angle. And so if you type this in, you're going to get about -5. There's going to be a decimal on there. I think my calculator says -5.0795, and it goes on a little ways. But just for time's sake, let's just go ahead and round here to -5. Then the y part would be 13 times the sine of 113 degrees. So if you type that in your calculator, you're going to get about 12. So my x direction is my horizontal piece, and that corresponds to this part right here. And we can see that that's definitely negative. And then over here, we've got 12 for the vertical piece, and we can see that that piece is positive here, which is good. And then for our vector ordered pair, we're going to have -5. You just simply list the x and the y component, and then you're good to go. Let's try the next one. The next one's similar to part A. Here we have 6 units west and 2 units south. So if we go right to the vector ordered pair, 6 units west would be -6, and 2 units south would be -2. If we think about that here on the coordinate plane, always a good idea to graph these things. We're going to go 6 units to the west and 2 units to the south. So here's what my vector might be right there. So that would correspond to -6, and then this guy right here would correspond to -2. If we want to find the magnitude of this vector is going to be equal to the square root of the x component squared plus the y component squared. That's just the Pythagorean theorem right there. So now we have the square root of 36, and that's going to be a positive 36 plus 4, which happens to be the square root of 40, which is also 2 root 10. Remember that 40 can be broken into 2 different factors of 4 and 10, and the square root of 4 is 2, and then 10 needs to stay underneath. So that's going to be our exact. Of course, you can type this in a calculator and hit enter if you need to get an approximate. For the direction, we're going to want to find the inverse tangent of the y value, which is -2 over -6. So be careful with this one though, folks. If you do type the inverse tangent in, -2 divided by -6, your calculator is not going to give you, oops, that shouldn't be on the video. There we go. Is going to give you 18 degrees, and that's clearly not correct. So 18 degrees is actually right here. So what are we going to do in that case? Well, we're going to have to take what our calculator gives us, and we're going to have to add 180 degrees. So this one should be 198. So if you graph these things, it really can help you with some times when your calculator won't give you the correct answer. 18 would be wrong for this one. It's actually 198 degrees. Let's move on to the last one here. So this is most like part B from before. I'm going to go ahead and draw this so that my brain can kind of wrap its head around what's going on here. So we'll do this here. And then we've got a magnitude of 10 units and a direction of 3/15. So that'll split this quadrant. So then that's going to be 10 units here. And this angle right here will be 315 degrees. So that's what that thing kind of looks like. Once again, we're going to go ahead and find our x and y components, and then that'll give us our vector ordered pair here. So I'm going to do, oops, shouldn't have written that. Get ahead of myself here. So we're going to do x, and that's going to be 10, the magnitude, which is the same as the radius for polar. And then we're going to do times the cosine of 315 degrees here. Now, you can actually figure out exactly what this one is. So I'm going to take you through that process so that you can find the exact value. That'll work sometimes. That should be just a degree symbol up here. Having a tough time with the stylus, I guess. All right. Come on, erase. All right. So then we got 315 degrees. And if we think about the cosine of 315 degrees, that is actually -√2/2 using our knowledge from a previous unit when we went over some right angle trig. Well, if we multiply 10 times -√2/2, 10 divided by 2 is 5. And I definitely want to write that negative sign out front. So we'll write -5√2. Now, we might ask ourselves, or actually it's positive. √2, I was going to ask, should it be negative? And it definitely shouldn't be negative. I'm getting way ahead of myself here thinking about the sign. So anyways, this should be positive 5√2. And I caught my mistake there for this reason. So if you go to the right, you're going to have to go to the right and down to get to this terminal point here of that vector. So we know to the right is going to be positive. So I'm going to list this as positive 5√2. If I really want to, I can go ahead and start my vector ordered, and try to squeeze this in here, vector ordered pair right now. And then if we think about the y value, that's going to be 10 times the sine of 315. Here's where your negative sign is going to come into play. So that'll be 10 times negative root 2 over 2. And that, of course, is negative 5 root 2. So there's your vertical piece, negative 5 root 2, or your y component. And we'll write that down here, negative 5 root 2, and we'll close that one off.